Alright guys, so let's dive into chapter 20. Chapter 20 deals with carboxylic acids. And then we'll continue that theme into chapter 21, which is carboxylic acid derivatives. So we've seen carboxylic acid structure before. We know what they look like. Right, we have this functional group here acting as our carboxylic acid. We often write it out like this. The other abbreviations that we see as we write it out is an RCO2H or simply an RCOOH. So carboxylic acids can be classified into two categories: aliphatic carboxylic acids or aromatic, which is you're part of a ring, a benzene ring or aromatic ring here. The carboxylic acids are acids, right? So they will undergo an acid-base reaction with water. So we see water coming over, grabbing that H to form H3O plus. So here's our H3O plus, and then we get our carboxylate ion, and this of course has resonance. So we come over just like so and do that, right? So the resonance structure of this would be that structure. And remember, acids are stronger when they have more stable conjugate bases. So normal OHs have pKa's of around 16 to 18, depending if you're primary, secondary, or tertiary, where carboxylic acid has a pKa somewhere in the realm of about 5. So that's a difference of 16 to 5 is 11, so 10 to the 11 times stronger of an acid, mostly because of that resonance structure. Let's talk about nomenclature a little bit here. So nomenclature is fairly straightforward, as we've seen so far throughout the semester. We're going to find the longest carbon chain that contains that carboxylic acid functional group. That's going to be your parent, and we're going to number it nearest the COOH group. Now we're going to add the suffix enoic acid. It could also be enoic acid, right? So it's oic acid, which is the key point. If it's an alkane, it'd be an anoic acid. And then we name substituents and we assign stereochemistry where necessary. So why don't we take a look at an example here. So let's see if we can name the following molecule. So let's put an OH and a carbonyl here. Let's come over and then let's do this. We'll make that a bromo group. So the first thing we have to do is count up our carbon chain here. We've got 4 carbons here. So bute is going to be our count for that. And this is an alkane, so it's going to be a butane. And then it's a carboxylic acid, so it's going to be a butanoic acid. And then the rest of it is just your basic nomenclature stuff that we've talked about all along. So here we have carbon number 1, 2, and 3. So that's a 2-methyl, right? So you got a 2-methyl there, and then we have a 3-bromo. So then that's a 3-bromo. And then we put that together, and we put it together in alphabetical order. So this is a 3-bromo, 2-methyl butanoic acid. Now we're not done, because at carbon number 2 and carbon number 3 we have stereocenters there. So let's take a look here at this position. So let's look at our CH3, and let's go ahead and put our H in there too. Okay, so for the time being, I'm going to go ahead and I'm going to cross this out so that it doesn't confuse our numbering here. Okay, so let's number. That H is number 4, right? That C of CH3 is number 3. And then which side is going to be our number 1 here? Well, it's oxygen, right? A carbon with an oxygen, or a carbon with a bromo. So that's going to be your number 1. That's your number 2. So then we're moving around from our 1 here to 2 to 3. So it's this direction. So that is the S direction. Okay, and then number 4 is pointing away, so we leave it the same. So over here, we're going to write a 2s. Let's look at number 3. So we'll go ahead and we'll put our H in here. Now remember, H is pointing at us. That's going to be your 4. Bromo's your number 1. This side's your 2. And this side is your 3 here. All right, so we're going 1, 2, 3. We're going around also in the S direction. But because 4 is pointing at us, we have to switch to R. So that's going to be a 3R on that. Now, ring systems, cycloalkanes in particular, will be named as cycloalkane carboxylic acids. So let's take a look at a simple example here with you guys. So 5 carbons, so that's cyclopentane, right? And then we're going to put off of this a carboxylic acid. So then the name of that would simply be cyclopentane, and then we add the word carboxylic acid to it. Okay, so we just know that, all right, you have a cyclopentane to draw, and then you need to put a carboxylic acid as a functional group sticking off of that thing. So let's look at this molecule. Let's put a double bond here, carboxylic acid here, and then how about a bromo group right here. So here we have a cyclohex, right? And it's a hexene. Right? Now this is our number 1. So it's a cyclohex 1 ene, right? And then this is 2, and that's a 3. So that's a 3 bromo. So putting that together, we have a 3 bromo, cyclohex 1 ene, and then carboxylic acid. Right, now it's assumed that that carboxylic acid is at number 1, so we don't need to say 1 there. All right, so the only thing left that we have is the stereocenter here at the bromo position. So crossing that out to limit confusion. There's our H. Our H is number 4, bromo's 1. This side's number 2, that side's number 3. So we're going around that direction. That is the S direction. So we can just write an S right there. You don't need the 3 because there's only one stereocenter there. All right, guys, so let's take a look at some common names here of carboxylic acids. And these you should just commit to memory. They come up throughout really the rest of your chemistry life. So 1 carbon would be methanoic acid. That's the IUPAC name. And the common name of that is formic acid. So formic acid is what red ants inject into you when they bite you, and it burns. Ethanoic acid is the IUPAC name of acetic acid, so we rarely call it ethanoic acid. So you may be familiar with at least those first 2. 3 carbons is propanoic, but it's often called propionic acid. 4 carbons, often called butyric, and 6 carbons, caproic acid. So that right there is OIC, oic acid, right? All right, guys, so let's take a look at some other common names. These are of benzene rings. So we know benzoic acid. We've seen benzoic acid before, and we've actually seen PABA, para-amino benzoic acid. All right, so remember that's your PABA. We talked about that when we talked about sulfa drugs. You have salicylic acid, and then we'll see in this chapter that we can make acetyl salicylic acid, which is aspirin. And then we have toluic and naphthoic acid. So those are a little bit less common. They don't show up that much in this chapter, but the first 3 do. And then there's some old systematic common names, and these names are often used in biochemistry. So I want to give you guys an example of one of these problems here. So let's look at this structure, NH2, and let's put here a CH2, a CH2, one more CH2, and then a carboxylic acid here. Right, so the older system of naming these things was to take our carboxylic acid, and of course that's going to be that would be your number 1 position right there, right? And then kind of numbering off of this, we would call that alpha, beta down here, and gamma. And this group right here, because we're part of a higher priority containing functional group molecule, that NH2 will be called an amino group. So this compound's name is gamma amino, because that's where the amino is, and that's butanoic, but often referred to as butyric acid. So this is gamma G A B A. So if you've taken physiology, you may recognize this as being GABA, or at least be familiar with the name GABA there. Now, dicarboxylic acids and salts, those are the last two categories of carboxylic acids that we need to talk about. So dicarboxylic acids, based on the same principles we saw before. So we're going to find the longest carbon chain that contains both of these carboxylic acids. Right? Number nearest the substituents. That makes sense. We want the lowest possible numbers, right? Count the number of carbons, add the suffix di, because we have 2, and oic acid here. So if you look at the structure down here below, let's count them up. So 1, 2, 3, 4, 5, 6, 7. Right, so 7 is hept. Right? And then it's an alkane, so heptane, and then dioic acid. So that describes the molecule with the exception of this methyl group at position 3. So then we put a 3 here. It's a 3-methyl heptane dioic acid. And then the only other thing that we have left is we have the stereochemistry at this position, because that's a stereocenter. So let's go ahead and see if we can figure that out. So here we have number 4. This is number 3. This side's your number 1. That side's your number 2. So we're moving around from 1 to 2 that direction. So it's going around like this. That is the S direction, and H is pointing away. So we leave our answer like that. And the full name of this would be S, 3-methylheptane dioic acid. So let's take a look at common names of dicarboxylic acids. These are especially important if you ever take biochemistry, or if you plan on going to medical school or pharmacy school or dental or anything like that. They pop up because they're common names of molecules that show up in things like the citric acid cycle. So it's easy to remember this. There's a little mnemonic that I'm going to show you guys. So if it's a dicarboxylic acid, the smallest number of carbons we can have here is 2. So oxalic acid is something that you may remember seeing in general chemistry, but that would look like this. So that is oxalic acid. All right, so malonic acid, we're simply just, I won't draw all of these out, but malonic acid, all we're doing there is putting a methyl right between those carboxylic acids. So that would be malonic acid, right? And then I'll just do this, ... etc. Right? We get that. So the key to remembering this is to remember this mnemonic. So, oh my, such good apple pie. Right, so here's oxalic, right, for the O, malonic, succinic, glutaric, adipic, and then pimelic here. Right, so if you know that you're starting off with 2 carbons for the oxalic, then you can work your way through this, and it'll help you remember G's glutaric, for example. That's commonly useful, by the way, for like multiple choice questions. Unless the question has 4 answers that start with the letter G, then it makes it not that useful. But anyway, it's a nice way that I use to kind of remember the order of these dicarboxylic acid common names. Now, the nomenclature of carboxylic acid salts, or carboxylate salts, is fairly straightforward too. In fact, you already know how to do this. So let me show you guys this. CH3, OH, right? That's your carbonyl here. So that's acetic acid, right? And that can become this, and that is acetate. So look, the ic acid part was replaced with ate. Just remember that, and you will remember how to name carboxylic acid salts. So again, the idea is name the related carboxylic acid, then we're going to replace ic with ate. And then it's because it's an ion, if we're giving the full name, we'll have to name the positively charged ion in there too. So I'll show you it's fairly straightforward, but let's take a look at this. Right, and then Na+. So first part's easy, right? Sodium. And then this has a couple different names. So it's butanoic acid, or also butyric acid. So then what we're going to do is we're going to get rid of the ic part here and the acid part. So that part we toss to the curb. And then we replace that with ate. So then butanoic would be butano8, and butyric would be butyr8. So in this situation, we can use either. So I'll just pick the top one. So this is sodium butanoate. Right, that's kind of the idea there. So it could be sodium butanoate or also sodium butyrate.